3.3 in the textbook is mass percentages from formulas. And there's two different types of problems here. Whether you're finding the percent of something, like the percent females in the class, so more generic, or finding the percent of an element in a chemical formula. So percent, and it doesn't matter which one, it's basically done the same way. Percent is the part over the whole. So mass percent, this is the first formula for the chapter that's given. So all the other formulas from section 3.1 and 3.2 are not given. Is the mass of A, so it's the mass percent of A. So whatever you're finding the mass percent of, the mass of that something goes as the numerator over the mass of the whole. And so that's probably the hardest part of doing this problem, is identifying whether what part is the part and what part is the whole. And then I can rearrange this formula to find the mass of A by multiplying the mass of the whole times the mass percent divided by 100. Okay, so this formula is also not given because it's just a manipulation of this equation right here. So how do you do problems like this? Okay, number 50 in the textbook says that a 6.01 grams aqueous solution, which just means it's a mixture of in water, okay, of isopropyl alcohol, which is also rubbing alcohol, contains 3.67 grams of isopropyl alcohol. What's the mass percent of isopropyl alcohol? So because it wants to know the mass percent of isopropanol, that automatically identifies the mass here, 3.67 grams of isopropanol, as my part. But when I'm doing numerical problems like this, I want to write down all my amounts and identify them. So I have 6.01 grams of an aqueous solution. I have 3.67 grams of isopropyl alcohol. And I also write down what I want. So the mass percent of isopropyl alcohol. And so, as I said, because this is the mass percent of, this is A, so therefore this has to be the mass of A. So the aqueous solution is the whole, the isopropyl alcohol mass is the part. And then I simply plug it into the formula of the mass percent of isopropanol is the mass of isopropyl alcohol over the mass of solution times 100. And then I plug my numbers in, 3.67 divided by 6.01 times 100, and I get 6.11%. Okay, this one's a slightly different one. This one says seawater contains 0.0065% by mass, because there's all kinds of different percentages, we're just doing by mass, of bromine. How many grams of bromine are there in 2,563 grams of seawater? So again, I want to start out with writing down my numbers. Okay, so I have the mass percent is 0.0065%. The next part is how many grams. So what am I looking for? I'm looking for the mass of bromine in grams. And then I have the 2,563 grams of seawater. Okay, so since this is mass percent of bromine and it wants the mass of bromine, this is my part because of the mass percent is of bromine. So this must be the mass bromine, which by then definition leaves this as being the mass of the whole. So when I make the formula, it's the mass percent of bromine, the mass percent of bromine over the mass of seawater, mass of bromine over mass of water, times 100. Now, I usually suggest actually circling what it is I'm looking for. Isolate it in some way so that you can see it. So I want to leave this by itself and manipulate the equation so that that's the only thing on one side of the equation. So to do so, I'm first going to get rid of my fraction by multiplying by the mass of seawater on both sides. So I get mass of bromine times the mass of seawater is equal to the mass of bromine times 100. I recircle mass of bromine because I still want to isolate that. I want that by itself. So whenever I'm doing these equations, this was division, so the opposite of division is multiplication. This is multiplication, so the opposite of multiplication is division. So now I want to divide both sides by 100. So I get my formula. And then once I get my formula, I plug in my numbers. So 0.0065 times the 2,563 divided by 100 is the mass of bromine. And when I do that math, I get 0.17 grams is the mass of bromine. Now, so that's using it as finding the percent mass of something. We can also find the percent of an element inside a compound. you basically do it the same way, except for my part and my whole are from the molar masses. So calculate the percent composition of each of the following compounds. So I have dihydrogen dinitride. Okay, so I have 2 hydrogens times 1.01 is 2.02. I have 2 times 14.01 is 28.02. Add those up and I get 30.04 grams per mole. So the percent hydrogen is the mass of hydrogen over the total mass, or the 2.02 divided by 30.04 times 100. So I have 6.72%. The percent nitrogen is the mass of nitrogen over the total mass times 100. So I plug in those numbers and I get 93.3. And then as a check, okay, if this is the whole compound, it should add up to be approximately 100. And it's very close, and it's just a rounding error is the reason it's not exactly 100. Part D of this one is magnesium nitrate. Okay, so magnesium is the main group metal. So magnesium has a molar mass or atomic weight of 24.31, and there's 1 of them. Nitrogen, there's 2 of them, and each one's 14.01 to give me 28.02. Oxygen, there's 6 of them because it's the 3 times the 2 times 16 gives me 96. So when I add those up, I get 148.33. So the percent magnesium is the mass of magnesium over the total mass, or 24.31 divided by the 148.33, I can't read, times 100, gives me 16.4%. The percent nitrogen is the mass of nitrogen over the total mass, or 28.02 divided by the 148.33 times 100, and I get 18.9%. The percent oxygen is the mass of oxygen over the total mass times 100. So 96 divided by the 148.33 times 100 gives me 64.7. And again, as a check, when I add all 3 of these together, 64.4, 18.9, 64.7, I end up with 100%. And that is the end of